This conference will now be recorded.
That's the sound of GoToMeeting, which we're using to record this session. At Aspire Test Prep, we use GoToMeeting teleconference software to bring world-class SAT and ACT instruction to any student in any location. We've made ourselves masters of the SAT and ACT, so you don't have to. You can just learn from us, get your score, go to your dream college, and move on with your life. But why should those who afford one-on-one tutoring have all the fun? We put these free instructional videos online in part because we believe that all hardworking students should have access to some of the world's best test prep instruction. And we appreciate anyone who feels compelled to become part of our team by supporting the production of our free instructional videos on Patreon. Just follow the links on this video if you'd like to go ahead and support our videos. Now, let's get started with our lesson on assembling two expressions and relating them. This is a wonderful topic because more than the specific question type being addressed, it's a general approach to the SAT on the math side. Because a lot of the time when you're approaching a problem, you have a feeling of, what can I do to solve this problem? And of course, anyone logically would be thinking something like that. But the problems lend themselves much better to an approach that says, what can I do with the information I'm given? What equations can I write with this information? So for instance, here we have the mean of 40, 60, and 80, and we have the mean of 25, 35, and some unknown number. And the question is basically saying that average number 1 is 25 more than average number 2. And so that's the unifying statement. And we're just going to go ahead and fill in the pieces of that. So average number 1 is the average is the sum over the number of pieces. So the average of 40, 60, and 80 is the sum of 40 and 60 and 80 divided by the number of pieces, which is 3. And that's 25 more than the average of 25, 35, and an unknown number, the sum of them divided by the number of pieces. So we can go ahead and calculate the sum of 40, 60, and 80 and then divide by 3, and we'll get 60. And that's equal to 25 plus, here we can combine like terms. So we have 60 plus x over 3. Now we can take away 25 from both sides. And that'll give us 35 equals 60 plus x over 3. Now we can multiply both sides by 3. And we'll have 105 equals 60 plus x, because these two 3's cancel together. Take away 60 from both sides now. And you get x equals 45. So the answer here would be A. Now, when we start a new problem, you'd be best served by pausing the video when you see the problem and going ahead and trying to solve it on your own, and then go ahead and unpause to see our lesson and our solution. So as we go to number 2, this would be the time to pause this video, but it's the same idea as the last one. We're being told that the first average, which is this one, is 16 more than the second average, which is this one, including the third number, right? So the first average, 34, 42, 77, the sum of them divided by the number of pieces is 16 more than the sum of the next 3, 22, 23, and some unknown number divided by that number of pieces. This entire thing here calculates out to 51. 16 plus, here we can combine like terms. Now we can take away 16 from both sides. So we get 35 equals 45 plus x over 3. Now we can multiply by 3 on both sides. And we get 105 equals 45 plus x Now we can take away 45 from both sides. Solve that out. X equals 60, and the answer here would be C. So we're going to our next problem. And here's our little reminder to go ahead and pause the screen on this question so that you can try it yourself. And so here we have the first average is 12 less than the second average. So if something is 12 less than something else, the less than kind of can be expressed as adding a negative number to it. So we're taking away 12 from it is another way to say that. So for number 3, we can fill in the first average, negative 3 plus 17 plus 46 all over 3 is 12 less than the second average, negative 5, negative 7, and the third number divided by the number of pieces. This thing here, if you go ahead and just do that on a calculator, comes out to 20. Combine like terms here, negative 12 plus x all over 3. Now we can get rid of this 12. That's 32 equals negative 12 plus x all over 3. The next logical step is to multiply both sides by 3. So we have 96 equals negative 12 plus x. We can add 12 to both sides. And so we have x is 108, and the answer is B. So here we go. We're going to have another opportunity to pause your screen and try the next problem. That'll be this problem right here. So to solve this problem out, we have the first average is 15 less than the second average. The first average is 4, 34, 69 divided by 3. And the second average is negative 10, negative 12, and the third number divided by 3. So now we can calculate here, get 35.6 repeated, negative 22. Okay, so we're just kind of calculating there. We can add 15 to both sides. So that's going to give us 50.6 repeated equals negative 22 plus x over 3. Multiply both sides by 3. So we have 152 equals negative 22 plus x, because in this situation the 3's canceled. And the next thing is going to be to add the 22 to both sides. And x is 174. So the answer here is C. Okay, going on to our next question. Number 5 there. So here we have the different weights for the puppies. The thing that stands out is that this one's an unknown, but the average of Emily's puppies will still be, all these green numbers plus x divided by 6. So the average is still the sum of the 6 numbers and divide them by 6. So let's go ahead and give that a try. So we have the unifying statement. Emily's puppies are, or the average of Emily's puppies is 0.8 more than the average of Maria's puppies. So we'll just give that as a general framework. Emily's puppies have an average of 0.8 more than Maria's puppies. So now we can go ahead and fill in the sum of all of the green numbers is 9.7 plus the unknown one, and we're dividing by 6, equals 0.8 plus, and the sum of all these blue numbers is 15.6. So there we have 15.6 divided by 6. So that number there comes out to 2.6. So we can combine that and we get 3.4. Now we can multiply both sides by 6. And you have 9.7 plus x equals, and 3.4 times 6 is going to be 20.4. And now you can take away 9.7 from both sides. And x is 10.7 right there. So the theme in this entire folder of problems here is to create that unifying statement and fill in the pieces from there. And that's as opposed to saying, what was the answer? Instead of saying, what's the answer, we're saying, what can we do with the information we're being given? So here we have Guillermo's average, which is 5.0 less than Ramesh's average. So Guillermo's average, which is going to be all 7 of these, plus the x, and we're dividing by 8 because there are 8 of them. So Guillermo's comes out to 590 plus x. So the yellow ones are 590 and the green one is x, divided by 8 equals -5 plus, and when we add up all these blue guys here, we get 708. 708 divided by 8. So that part there comes out to 88.5. Bring down the -5, bring down all this stuff. With a little bit of bad handwriting there. Okay, and now we can go ahead and combine the -5 and the 88.5. So you'll have 83.5 is equal to 590 plus x over 8. Now just multiply both sides by 8. 590 plus x equals 668. And we can take away 590 from both sides. And x comes out to 78. And if I ever shoot 78 in a single round of golf, I'll be ready to retire from the sport. So going over to the next question now. Good chance to pause and go ahead and try this question on your own and then look at our solution. There's the question. It's a very difficult one. So this is something that I refer to as changing levels. It's another thing, and you'll see lessons on just this topic. It's one of the tougher SAT topics, but we're going to just jump right into it. When you have this question type, you're looking to see by what percent something changed, and that's as opposed to finding out what the actual area is. We're finding how much it changed. We're not finding what it actually is. So the way to do this is to start with your starting formula. We'll call this A1, the original area of the triangle. And A2 is going to be what happens when you increase the base 15%. Let's talk about that really briefly. With percents, everything starts at 100%. So right now, if you're listening to this video, there's 100% of you listening to this video. If you take away 15% from that, it's going to leave you at 85%. And if you add 15% to that, it's going to take you to 115%. Now, those are the percents, but you need them to be in decimal form for you really to do any math with them. So to get from decimal form to percent form, you're just going to move the decimal over 2 spaces. So 85% becomes 0.85, and 115% becomes 1.15. And there you have it. So to increase the base by 15%, means we're going to take the base and multiply it by 1.15. So we had b before, now we have 1.15b in the same formula. With the height, it's a lot more complicated because we have an unknown percent change. Same underlying concept though. So if I have 100%, let's think of it as on the left, we're taking away x percent, and here we're adding x percent. So we're doing the same thing we did in black, but we don't know the actual percent. So let's just think about what 100% is. Percent means over 100. So another way to say 100% is to say 100 over 100. And if we're taking away x percent from that, percent means over 100, so we're taking away x over 100. Similarly, on the right, if we're adding x percent, adding an unknown percent, we have the 100%. Percent means over 100, so that's 100 over 100. And we're adding x over 100 to that. So to just make it look a little neater, we have the same denominator anyway, so we may as well combine it into a single statement there. So we can just say 100 minus x over 100 for an unknown percent decrease, or 100 plus x over 100 for an unknown percent increase. So if I'm adding 15%, it would be 115% or 1.15. If I'm adding x percent, it's 100 plus x over 100. There are a couple more complicated ways to show that, believe it or not, more complicated than that. But anyway, so for the height, we're going to multiply, this is being increased by x percent, so that's the 100 plus x over 100. So those are our expressions for each of the areas, area 1 and area 2. However, the problem says these changes increase the area by 25%. So the new area, area 2, is 25% greater than the old area. And the million-dollar question here is, what goes in those parentheses? How do you express 25% greater? So according to that lesson on the top of the screen there, the one I'm circling in blue, if we're adding 25%, that means that we're multiplying by 1.25. So now let's just fill in everything else we have. It looks complicated, but you'll be amazed at how it all simplifies in a sec. 1/2, 1.15b, 100 plus x over 100, h equals 1.25 times 1/2 bh. So if that looks complicated, you're right, but the good news is it's about to become a whole lot less complicated because you can divide 1/2 from both sides, you can divide b from both sides, and you can divide h from both sides. When the dust settles there, 1.15 times 100 plus x over 100 equals 1.25. And it's a lot simpler. So another really simple way to proceed from here is to just divide by 1.15. So that actually gives you, on the right-hand side, 1.086956. It's a never-ending decimal, an irrational decimal. And on the left, just the 100 plus x over 100, because the 1.15s canceled away. Now we can multiply both sides by 100 to get rid of the denominator on the left, and you'll have 100 plus x equals 108.6956 blah blah blah. Take away 100 from both sides, and x equals 8.6956, never-ending decimal, and we can round that to b. So it's definitely a tough question, but it's doable. And like most SAT concepts, with a little practice, it's much more doable. So here we have the same idea. We have a rectangle in the beginning. The area of a rectangle is base times height. So we'll call that area 1. Area 2 is we're decreasing the base by 15%. That means we're keeping 85% of it. So we're replacing the base, replacing b with 0.85b. And according to what we said on question 7, We're decreasing the height by an unknown percent. So instead of h, we're going to call this 100 minus x over 100 times h. And if you're jumping around in this video, the explanation for why that is in question 7. But the unifying statement is the second area is 60% of the first area. Because if I decrease the area by 40%, you start at 100. 100 minus 40 is 60, and in decimal form, that's 0.6. So we can go ahead and fill in our A2, 0.85b, 100 minus x over 100 times h, that's A2, equals 0.6 A1 BH. And here's the beautiful moment where everything cancels out. So just to rewrite, just for neatness, 0.85, 100 minus x over 100 equals 0.6. We can divide now both sides by 0.85. And we have 0.70588 on the left. So we've got 100 minus x all over 100 equals 0.70588. Multiply both sides by 100, and you get 100 minus x equals 70.588. Take away 100. Negative x equals negative 29.41. Divide by negative, or multiply by negative 1 to get rid of that negative sign. And x equals 29.41. And so the answer is A. Okay, number 9 does the same idea with something added in there, which is the idea that we're dealing with the area of a sphere, which has something to the third power in it, the volume of a sphere, which has exponents to the third power. So the volume of the first sphere is just the volume of the sphere formula, 4/3 pi r cubed. It wouldn't hurt to know that formula without having to look it up. The new volume of what's being described has the idea that the radius is increased by an unknown percent. The unknown percent increase we talked about on question 7 is represented as 100 plus x over 100. So everything's the same except we replaced r with 100 plus x over 100 times r. So the handwriting is a little iffy there. But the idea is that this is kind of protected by a parentheses there. And that whole r is being multiplied by the 100 plus x over 100, representing the fact that it was increased by an unknown percent. So the problem tells us that the second volume is 33% more than, we explained why that is in question 7, the first volume. Now we can fill back in. V2 is 4/3 pi 100 plus x over 100 all times r cubed equals 1.33, and 4/3 pi r cubed. 4/3 cancels with 4/3, pi cancels with pi. And let's go ahead and rewrite that one more time. 100, a lot of rewriting for me here. 100 plus x over 100 r cubed that parentheses is actually not accurate. The cubed is the parentheses is kind of right there, equals 1.33 r cubed. So we have it up to there. And we can take the cube root of both sides right now. Actually, before we do that, if this entire thing is to the third power, that's equivalent to saying 100 plus x over 100 to the third power and r to the third power, because it's the idea that everything in there is to the third power. Now this is necessary because now we can divide both sides by r to the third and they cancel away. So we just reduce the sort of complication of everything by totally eliminating one of the variables. Rewriting now 100 plus x over 100 cubed equals 1.33. Now we can take the cube root of both sides, which is the opposite of having something to the third power. 100 plus x over 100, and the cube root of 1.33 is 1.0997. Now, by the way, the cube root on your calculator is the same as raising something to the 1/3 power. That's how you can do that on, let's say, a TI-84 calculator, which is what we recommend for the SAT. So right now we have it there. We're going to multiply by 100 to get rid of the denominator on the left-hand side. And we've got 100 plus x equals 109.97. Take away 100. And x equals 9.97. And we are done with that question.
This conference will now be recorded.
Just pause the recording of the video for a second. That's why you heard the notification that it's being recorded again. But going back over to question number 10 now, it's an entirely different kind of question, but it's the same approach of assembling two expressions and relating them to one another. So here we have a total cost of $2,500. It's being shared by a certain number of students. So the original cost in this problem is 2,500 divided by x. Then we have 5 students backing out. So the cost is now 2,500 being divided by 5 less people. The unifying statement is this. The new cost is 25 more than the old cost. So the same process we've been doing before. Just go ahead and fill in what we have. 2,500 over x minus 5 equals 25 plus 2,500 over x. Now here's where this problem is different than anything we've done so far in this video. This is what you call a rational equation. A rational equation is where you've got denominators that are polynomials. And what you essentially will do if it's a rational equation is multiply both sides by the denominator you don't want. So we don't want x on the bottom, and we don't want x minus 5 on the bottom. So I'm going to multiply by both of those on both sides. When you multiply here, the x minus 5s cancel, leaving you with the x. So we have the 2,500 that was there and the x that was there. When you multiply, when you multiply here, nothing cancels out. So I've got 25, it's being multiplied by x, and also by x minus 5. And when we go here, now the x's are canceling. So I have x and x minus 5 being multiplied by 2,500 over x. The x cancels, leaving you with 2,500 times x minus 5. So now we're just going to kind of distribute and start solving. So here, distribute to here and here. That'll give you 25x squared minus 125x. Distribute here and here. That's 2,500x minus 12,500. And we've got 2,500x here and here. So we can subtract those from both sides and they would just cancel away. So rewriting it, 0 equals 25x squared minus 125x minus 12,500. And a nice way to simplify here is to divide both sides by 25, because if I do that, the 0 stays 0. 0 divided by 25 is 0. But on the right-hand side, you have x squared minus 5x minus 500. So now we're in a position of BC factoring. So anyone who doesn't know what that is off the top of their head, you can just Google BC factoring and see what comes up. But the idea here is that we're looking for two numbers that add to negative 5 and multiply to negative 500. Now, if it's a complicated number like, complicated set like 5 and 500, you want to start with the multiplication first, because there are actually an infinite number of pairs of integers that can add to negative 5. Any pair of integers where one is 5 more than the other, in theory, or 5 less than the other, will add to negative 5. But we can go ahead and take 500 and just divide it by every possible number. You don't have to catch every one, but we're looking for a pair of numbers. So 500 divided by 1 looks like that, right? 500 divided by 2 would be 2 times 250. And we're looking for a pair of numbers that when you add them together, you get negative 5. Again, and one of them can be negative. That's okay too. So as I make my list, I'm going to divide it by 5. 5 times 100 divided by 10. 10 times 50 divided by 20. And I get 20 times 25. And that's actually our pair of numbers, because 20 minus 25 is negative 5. So I have x minus 25, x plus 20. So negative 25 and positive 20, they add to negative 5. They multiply to negative 500. So it works perfectly. And so now we have the zero product rule. X minus 25 equals 0. X plus 20 equals 0. If you have two things that multiply out to 0, then you can set each one equal to 0. So we'll go ahead and do that, and we'll solve each one. So on the top, x equals 25, and on this one, x equals minus 20.
This conference will now be recorded.
And apologies once again for that notification, but basically from this quadratic, you get your two answers, because you have 25 and negative 20, with some bad handwriting there, negative 20. And of course, the negative number doesn't make sense in this situation, so the answer is 25, because you're not going to have a negative number of people. So looking now at number 11, the same idea. We have the original cost, which is the price divided by the number of people. The new cost, which is the price divided by, which is the same price of 1,200 divided by the number of people plus 4, because 4 more people are showing up. And the unifying statement right here is saying that the new cost is 25 less than the old cost. And so we're just going to go ahead and fill in what we have into that. 1,200 over x plus 4 equals negative 25 plus the 1,200 over x. And as we said, in rational equations, you're going to want to multiply by the exact denominators you don't want, which are x and x plus 4. So when you distribute into here, the x plus 4s are canceling, leaving you with only 1,200 and x. And when you distribute into here, nothing cancels. So you have negative 25 multiplied by x, also multiplied by x plus 4. And when you distribute into the third spot, the x's are going to cancel. So you have 1200 parentheses x plus 4. Distributing out a little, 1200x equals negative 25x squared minus 100x plus 1200x plus 4800. And now you can subtract 1200x from both sides, which will make these two things drop away. So with so much writing on the screen, I just want to make it really clear right now that we're talking about this problem here. So just rewriting, and we've got 0 equals negative 25x squared minus 100x plus 4800. And I'm going to go ahead and divide both sides by negative 25. So you get x squared plus 4x minus 192. And why negative 25? Because in a quadratic, when you have something in the ax squared plus bx plus c format, which is what we have here in purple, that's considered a quadratic. You want it equal to 0, and you also want the x squared term positive if you can help it, because that's the situation in which you do factoring. So now BC factoring, which like I said before, if you don't know what that is, you can Google what's BC factoring for a quadratic. Here we're looking for two numbers that add to 4 and multiply to 192. And if it doesn't automatically occur to you what numbers those are, you just take the thing you're multiplying to, and you divide it by every number you can. So 192 is 192 times 1. It's also 86 times 2. It's also 64 times 3. Dividing it by 4, you get 48 times 4. It divides by a lot of different numbers. You can also divide it by 6. It becomes 32 times 6. Dividing it by 8, it becomes 24 times 8. And dividing it by 12, and it becomes 16 times 12. And those are our numbers, because the two numbers that will add to 4 or multiply to negative 192 are negative 12 and positive 16. X plus 16, x minus 12. Now we have the zero product rule because we have two things, these two pink things. They multiply out to 0. So mathematically, that means if two things multiply out to 0, one of them had to be 0. That's the only way anything would multiply to 0 is if one of the numbers was 0. So the rules of math, the zero product rule, says that that's the situation where you set both parts equal to 0. X equals negative 16, x equals 12. And as I said on number 10 as well, the negative number is not relevant here because you can't have a negative number of people. So the answer ends up being 12 for number 10. For number 11, excuse me. So now we're going over to number 12, to question 12. And as we've been saying, you can pause the screen and go ahead and try the question on your own, and then look at our solution so you can see if you're really getting it. So here, the original cost for the fractional boat ownership club, which I'd love to be a part of at some point in my life, the original cost is 2,400 divided by the number of people. The new cost is 2,400 divided by the new number of people, which is x plus 10, because 10 more people are joining. So just to kind of center us and show that we're working on question 12 here. So the unifying statement is telling us that the new cost is 12 less than the old cost. The cost went down by 12. So we'll go ahead and shrink that to have more room. And we can fill in everything we have right now. So C2 was the 2,400 over x plus 10, negative 12, and 2,400 over x. And for the rational equations, we're going to multiply by the exact denominators we don't want anymore, which are Just making sure all my pens are the right size here, which are x and x plus 10. So now we have 2400x equals negative 12 times x plus 10. So we're distributing right now. We just did this part, and now we're going to do this part. So when you distribute this part, the x's cancel, leaving you with the 2400 and the x plus 10. So plus 2400 x plus 10, distribute out a little. 2400x equals negative 12x squared minus 120x plus 2400x plus 24,000. And here you can subtract 2400x from both sides. It'll make it look a lot neater. And 0 equals negative 12x squared minus 120x plus 2400. Dividing by a negative 12 because it's a lot simpler if you have the x squared term as the positive one. So dividing by negative 12 on everything gives you x squared plus 10x minus 200. So we'll shrink this down a little to get to the next column. And what two numbers add to 10 and multiply to negative 200? That's a little easier than before. The numbers that would do that would be x plus 20 and x minus 10. The zero product rule says that's where you set each of these equal to 0. And here you take away 20 from both sides. X equals negative 20. Here you add 10 to both sides, and you get x equals 10. So the answers are 10 and negative 20, but negative 20 doesn't really make sense. So the answer is x equals 10. Okay, so go ahead and pause your screen if you want to try the next problem. Number 13. It's a totally new concept, a totally new question type going on from what we were doing before. This is a little more like the one we referred to as changing levels. So here we're hearing about Gabriel's reception and Sam's reception. So the reception that belongs to Gabriel is the signal, which is universal, over the function of Gabriel's distance. So all I'm doing is taking this formula and I'm turning this into RG and this XG just to say it's the signal, it's the reception that belongs to Gabriel and the radius that belongs to Gabriel. Because of course, for the next one, we're talking about Sam. So the reception that belongs to Sam is equal to the signal over 4 pi and the radius that belongs to Sam squared. So we have the reception of Gabriel and the reception of Sam. The problem says that Gabriel's reception is 8 times Sam's reception. So for this problem, looking at it now, I might have wanted to call that reception. That might have been confusing, but for people who paused it and tried that problem, I might reword this as reception for using this worksheet in the future. But it was Gabriel's reception that's 8 times Sam's reception. And so now we're going to fill in everything we have. So S over 4 pi xg squared equals 8. And then Sam's reception, 4 pi xs squared. And this is that moment where a lot of things cancel out. Divide both sides by s, multiply both sides by 4 pi, and you get something that looks a lot simpler. So 1 over xg squared equals 8 over xs squared. So this 8 right here was on the top of the fraction because 8 is the same as 8 over 1. When I multiply it all together, the 8 is on the top and the xs squared is on the bottom. And if you cross multiply that, you'll have xs squared equals 8 times xg squared. Taking the square root of both sides, you get xs equals 2 root 2 times xg. So the square root of 8 is 2 radical 2. And if you need a lesson on that, go ahead and put a comment in the comment section. Definitely voting for what kinds of lessons you'd like to see in the future. But now Sam's distance, which is xs, is 2 radical 2 times Gabriel's distance. It's that many times stronger. So the answer here is D, even though for the signal here, the problem would have been better worded if we said reception instead of the word signal there, which is what we were going for when we wrote the problem. Something we'll definitely fix in the future. So going to this problem here, we have two celestial bodies. The rotational energy of one is 4 times the rotational energy of the second. So you have the energy of the first, which is 1/2. They have identical moments of inertia, but the W's for them are different. So I'll call this W1 squared. And for the next one, we'll say E2 is 1/2 I W2 squared. So the unifying statement is saying the rotational energy of the first is 4 times the rotational energy of the second. So E1 is 4 times E2, and we can fill everything in. And it looks like that. So now we can divide both sides by 1/2. We can divide both sides by I, rewrite it, and it looks like that. How many times stronger is the W of the first body than the second? We can take the square root of both sides. W1 equals 2 times W2. So how many times stronger? W1 is 2 times stronger than W2. Looking at number 15 now, same idea. You've got the force experienced by one object, by object number 1. G is a constant. They have identical masses, so I'll just call it M for both of them. And P is the mass of the planet, which doesn't change because we're talking about two different objects and the same planet. But the radius, the distance from the center of the planet is what's going to be different. So we'll call that R1. And for F2, we'll do everything the same, but we'll call that R2. So we set up the force for one of them, the force for the other. The unifying statement is that the closer object, which is the one that we refer to as F1, so we'll just go ahead and say this is the closer and this is the further so we don't get confused. But the closer object has a force that's 100 times the further object. So F1 is 100 times F2. Now filling into that, for F1, we had GMP over R1 squared. For F2, we have GMP over R2 squared. So we can divide both sides by G, divide both sides by M, divide both sides by P, and you get a much simpler looking statement. You have 1 over R1 squared equals 100 over R2 squared. Square root of both sides here. 1 over R1 equals 10 over R2. Cross multiply, R2 equals 10 times R1. What's the ratio of the distance from the center of the planet of the closer to the further? So that's R1 over R2. So R1 divided by R2. So you can divide both sides by R2. and 1 equals 10 R1 over R2. Now you can divide both sides by 10, which is the same as multiplying both sides by 1 over 10. And you have 1/10 equals R1 over R2. So the ratio between them is 10 to 1 or 1 to 10, and the answer is C. And that brings us to the end of this video. We really appreciate you. If you've made it this far into it, that right there shows your dedication to the SAT and to getting better and to getting into your dream college, which is a beautiful thing to see. We do one-on-one online SAT tutoring by world-class instructors. You can email us, give us a call if you'd like to find out more information, or if you just want to support the entire world getting these free SAT videos, you can go ahead and go to Patreon and support what we're doing, and we really would appreciate it. If you have any questions or comments, go ahead and leave them for us, and we would love to hear them from you.